Good morning, ladies and gentlemen. Welcome to the 2020 Wyong Field Day lectures. My name is Philip Collins and I'm introducing Ray Robinson, VK2NO, November Oscar, talking on the AR60 radio system.
Hi there, how's it going? Has anybody heard of the ARC60? Everybody knows about it, good. It was made by the A.R.C. Corporation, the Aircraft Radio Corporation, which is different to the AN/ARC, which means Airborne Radio Communications. So that's the official Army, Navy designation of the radio, but it was made by A.R.C., which is confusing. So normally you would say A.R.C. for the company and A.R.C. for the radios. But it wasn't made like that. It was made as the... Cool, I like that. It was made as the Type 12 because A.R.C. goes back to the days of the 30s when they were first making radios out of Bakelite, and they were making little parts. They invented AGC, or partially like that, part of that, and were offering that to other companies to make radios, and so they were kind of an inventor's shop sort of thing. But they weren't making radios as such. So Doolittle actually got A.R.C. to make them a radio, the Type B, because Guggenheim, who had made all his money out of mining, got interested in aviation, very early aviation, and there was no way to land in fog or rain or at night time. So Guggenheim offered this prize for the first blind landing or equipment thereof. So Doolittle got these people to make the Type B and they did the first blind landing and he got the prize, and A.R.C. got the kudos from this. And that receiver is actually in the Smithsonian in the USA. So A.R.C. went on to do all sorts of things, and they started making command sets, which I'll come to later. But all their radios had a different name, and this one was called the Type 12. And it was made after the war for civil aviation. When the war finished, all these big companies like, well, Collins wasn't in existence, but other ones like Bendix and Westinghouse, they had their contracts cancelled. So they had these huge factories making military radios and they couldn't sell them. But A.R.C. didn't fall into this trap because they wanted to stay small and they were subcontracting out. So when the end of the war came, they suddenly found they didn't have a problem, but they had no market. Because all the World War II radios were being used in aircraft, but suddenly there was this civil aviation interest. So people were buying Cessnas and those sorts of things and they needed a radio, so they made a little radio for them. And this is where the ARC60 came from. So after the war, they offered their World War II radios, like those, for big aircraft companies, like the Super Constellation. But they also made a little one suitable for small aircraft. And that's what this radio is, it's the little one. So here's one here, if you want to pass that around and look at it. So they pushed this radio and sold quite a few of them. So this talks about the World War II radios, the Type 12s, the name, and what happened after. Because the Type 12 was aimed at civil aviation, but by the end of the war, when Korea came along in 1950, the Army people suddenly said, oh, we need little radios for our helicopters and our light planes. What do we use? They adopted the Type 12 and used it for communication. So it suddenly got the ARC60 designation. They also made other radios which looked the same. One of them was a direction finder, looks very similar to that. Automatic direction finder, so you could find your way in your aircraft. They made another one for beam approach, so when you were coming up to the runway, you could land on the runway, so an indicator gave you where to go. And they were the the ARN 59, Type 21, and the Type 15, which was the ARN 30. I'm not going to talk about those, they're a completely different subject. So this is the one that's being sent around. They look like a World War II command set, but they have no dials. They're a cheapened version. They got rid of the dials, you didn't need those anyway. They put a few extra connectors on them, and the insides, which are all plug-in, suddenly they're all hardwired in. Now a dynamotor sits on the back and gives you 250 volts DC for 28 volts in. So it's one of the original DC to DC converters, a motor generator set. And it just sits on a shock mount here, and it's wired on for vibration. Motor commutator on one end, generator on the other, 28 volts to 250 volts DC. And the filaments would just run in series. The connectors were interesting. It's great stuff, isn't it? During World War II, they used this early type of connector with black Bakelite insulator. And there was always a screw holding it on, and the screw always earthed one pin, so you were stuck with an earth whether you wanted it or not. When they went to the A.R.C, they changed it to a ceramic insulator and a circlip to hold it in, so they could do whatever they liked. They didn't have to have an earth. And they had multiple pins from 2 up to about 19, depending on which connector you want. So a quick look at the insulator can tell you what series the connector's off. Connectors are hard to find, and there's so many of them. So they decided to adopt the ARC60 receivers, but they didn't adopt all of them. For instance, the broadcast band receiver, which was available in 14 and 12 and 28 volt, they didn't bother. Although they did use them later on, but they didn't officially become part of the ARC60. The navigation receiver, the LF1, was adopted. This receiver was not adopted in 12 volt, 14 volt, but the 28 volt one. Well, it was. Same with this one, but they decided to adopt it. But then there was a beacon receiver as well. So they picked and chose what they wanted to use and what they didn't. And the dynamotors, once again, they gave them their own numbers. So that's just the receivers. Then, of course, there were the transmitters. So these are the Vhf transmitters. And the antennas with their own numbers. And, of course, they had relays, oscillators and mounting. Many, many junction boxes and connectors and so on. Now, they did low VHF to start with, and they had also high VHF. And these ones are handy because they cover the 2 metre band. So this was for voice communications. The military band moved up to 200 megs. It was actually 200 to 400 megs. And they made this thing called a transverter, which was basically a single stage mixer down to work on the front of these receivers, and also a separate transmitter. So the transverter, that's a bit of a strange one. So for Vhf Communications, they mainly covered these 2 bands. And for navigation, they covered these 2. So for navigation, they'd use a DF loop. If you look down at my display down there, I've got a DF loop, and you can tune into a broadcast station or a beacon and use the DF loop to find out where it was, so you could use that for navigation. The beacon receiver, 75 megs, was when you were coming into land. You usually had an outer marker and an inner marker, so you knew where when you crossed the boundary of the airport. It's a very simple receiver, only a few valves in it, and pretty boring. This is the transmitter I was talking about, and I'm not going to mention those in this talk at all. Thank you. Okay, here, take this. Pass that around. That's a control box. So, oh, didn't you see it?
No. These guys here,
Dear, oh dear, oh dear.
that's why the pledge is sitting over here.
Can I have it back when you're finished?
Oh.
So the radios came in various sizes. I'm using the R10, which is the A.R.C Type 12 name, because the ARC60 didn't officially use it. But of course they did, but just didn't give it a number. So it looks like a normal World War II command set: audio, detector, IF, and mixer and RF amplifier. But they did lift their game a bit and use loctal valves rather than octals, although this is still an octal audio amplifier. They encapsulated all their capacitors in cans, which was a great idea. These ones are actually inductors, and there's an inductor there as well. And the wiring was simple point to point, but using plastic wire. And this is a little plug-in coil box, and you can see it's written 0.52 to 1.6 megs. So they're very neatly made.
It's all nicely operated. Was this like servo control?
No, it's a Boonton cable.
Oh,
So
mechanical,
it says a
totally
rotary,
mechanical.
totally mechanical, yeah. So this is what the block diagram of it was, the RF amplifier, mixer, a couple of IFs. But they did, the World War II ones had a BFO in. And since we weren't doing any Morse anymore in private aircraft, we had a spare valve socket, so they put in a noise limiter. And that's the audio amplifier driven by a dynamotor. So they changed it slightly. The filaments were available in parallel for 12 volt or series parallel for 28 volt. And that's about the only difference apart from the nameplate of the receiver. So here's the noise limiter, which was a double triode. The audio output just drove for headphones. All the connectors on the front did power in. A control box, that's the control box, yes. And this was actually a connector which normally had just a link in it. I'll come to that later. And the RF came in either through an antenna terminal or a loop terminal with a little relay. If you look on the front of the control box, there's a little switch which goes loop. That's the VHF one, that's different. Anyway, there's a little switch on the front which went loop, ordinary antenna, so you could use a long wire antenna or a loop antenna. The control box, which is going around, is very simple. There's a switch to switch the loop on and off, loop or aerial, ground, volts in for the on-off, and a gain control. And the gain control is 50K, so it's an RF gain control, not an audio gain control. And this is how you hook them up. Volts in, control box, pin for pin, and this link in here. So the HT is just connected to itself. Come to that in a moment. So this is the R10. Now the R11, almost the same, except it's a different frequency, 190 to 550, and it's got ARC60 designations as well. Very low IF frequency, 85 kcs. So this is it, looks the same. The only difference you would notice would be the nameplate. And these are the Loctal sockets and the normal tuning gang. Circuit's almost the same. Slight difference in tappings on the IF transformer, but much the same. So they also had, so these were for navigation. Then they went to VHF for communications, for voice communications, AM. So the low frequency one was 108 to 135. Higher IF, 15 megahertz. So stability wasn't really a problem with such a wide IF. You could oscillator could drift a bit and you could still get the voice in the channel. Once again, looks the same, different nameplate. The difference is there's a little squelch control here, which the audio limiter, if I go back, no, I have to go forwards. Around here, this is actually a noise control and there's the squelch control. So it's a slightly different noise limiter. The tuning capacitor was changed completely to a very high frequency, low capacitance one with various miniature tubes, mostly triodes, and one would be the local oscillator with multipliers and one with the mixer RF amplifier. And you can see the difference here. This is an octal socket for the audio tube and a loctal socket for the IF amplifiers. And you can see the IF amplifiers are screwed in, they are not unpluggable.
Did they have any captives on the miniature valve?
No, no. So the question was, are there anything to hold the valves in? No, just the spring contacts on the bottom, on the base. So once again, audio amplifier detector, IF, 3 IFs, and this little unit, which is the local oscillator and the RF gain. So you saw that, the difference being that this section is the VHF section. Now, these are great books. You look for them and you find errors. For instance, how does the plate voltage get from there to there? Wire missing. It's there in real life, but not on the circuit. So it's great you find all these errors in these things when you look closely. So it's the same sort of control box. The difference being that there's now a high-low switch here, so you can change the audio level. If you're listening to VHF, you get the high, noise, which is annoying. So you can change it by switching out the cathode of the audio amplifier and reduce the gain. So that's all you've got, really. Once again, same arrangement, volts in, control box, different control box, by the way, and this link. The R19, the same, except it covers a different frequency range. And once again, the ARC numbers. Looks the same. This one's a bit beat up. Once again, the squelch control telling you the difference between this and the low frequency receivers. Same circuit. This one actually has the wire in it. That's good. So the other connector, which one I was talking about, has got the link in it. The link was just a piece of Bakelite or fibre board with a little link on it, with a dust cap to stop you getting zapped because it had 250 volts on it. That's all it was. And if you're doing a receiver-only installation, that's all you do. You just put the cap on here with the little link, put your volts in there and your control box in there, and your drive here, which was a mechanical cable to do the Boonton tuning. So the only frequency control you've got, or really indication, is the control box with the dial on that. So if that cable comes off, you've got no idea where you are unless you do a calibration on the ground. So when we get to transmitters, the transmitters are only about half this size for several reasons. They're only running 2 watts and they've got no dynamotor. So where do they get their power from? They get their power from the receiver, and that's what that little link is. So the transmitters only came in 2 styles. Well, 2 basic transmitters, and one covered 116 to 132, and the other one covered 132 to 148. So there's only 2 of them. But then, during production, they changed the valves in them. They changed them from 6 AQ5s to 5763s. So now there were 4. And then they were available in 14 and 28 volt. So now there were 8. So they looked the same, but they were slightly different. And just to confuse it, the numbers were all over the place. A's, some had A's, some didn't. T11A becomes the 365, 366. But the B becomes an A, and the B becomes a 66A. But when we get to the 13, it's a 364, but it's not an A, like this. That's AB, this is just no number A, so numbering's all over the place. So there are basically 8 transmitters, but really only 2. So they had 5 crystal channels, merely selected by a rotary switch. Was another little control box with just a frequency switch on it. And the last position was for intercom. So the transmitter didn't work, but you still used the modulator as the intercom. You set them up and you tune them, and that's it. So you can't do wide frequency changes. All the crystals have to be within a 2 megahertz area of that tuning. So you were limited. You had to decide what frequencies you wanted and have your crystals, your channels, in that frequency. And your crystal, of course, was multiplied up 18 times or 12 times. So if you were multiplying 12 times, that crystal had to be in this range or this range, depending on which frequency you're going for. So there's the transmitters. I like this no step on it. Looks like a step, doesn't it? You can stand on that. So it had 2 connectors, a mic input, and BNC for RF output, and another connector which actually duplicated some of these controls. But nothing on the back, no racks. You didn't plug these things into racks. So here they are with the crystals, one with crystal plugged in, a couple of transformers, and these ones have got 5763s in, whereas the originals had 6AQ5s. And you can see the circuitry, it's very simple. The crystal sockets are under here, and the relays just select the crystals. And then they're multiplied up and comes out through the BNC connector. The crystals, doubler or tripler, could be a tripler, doubler, and modulator. Now, one of the interesting things is they're actually doubling in the final. So you'd have to be careful of your second harmonic, or your subharmonic if you like. So this is the T11B, which is the low frequency VHF one, AM modulated. Simple circuitry, crystals and relays, doubler or tripler, depending on your frequency you choose, and your tripler, your power amplifier, and your modulator, and your transmit receive relay. They were made to work with carbon mics, so they had a mic transformer. Very simple to wire up. The control box is just earthing one of the relays. So that's the receiver, which, remember there was a link on that connector which connected the HT in and out. Well, now it goes via the transmitter. So the transmitter will turn the HT on and off to the receiver and also use the HT to run the transmitter. And then that's the control box. The next one is the T13, which does the higher frequency. And this is an example of the higher frequency one. Looks the same, doesn't it? You could move the higher frequency one slightly down in frequency by putting this lump of metal on, which has even got an ARC part number. There's the part number and there's the A.R.C logo. And what it does, it goes around the valves and is bolted onto that transformer. Lowers the frequency just a little so you can change your frequency response of the higher one. Same circuit really. And once again the filaments are in series parallel or whatever because they're 6-volt valves, the other one had 12-volt valves. So if you had a receiver, you just had the control box with a link. If you had the receiver and transmitter, you had to use the other unit. that's great. You set up a crystal controlled transmitter, you have a receiver, but how do you know you're on the same frequency? They had to, an afterthought was netting, because in civil aviation you could just sit there on the runway and listen to the control tower and tune your receiver furiously and you'd know what the frequency was, no problem. During wartime or radio silence conditions, you wouldn't be doing that. So they had to put a net facility in it for when you wanted radio silence. This became a little bit more complicated because the radios weren't designed for this, so it became an afterthought. And they introduced the whistle through function. So this involved this little box, which at first sight looks simple, but it's not. The first thing they did was when they wanted to net the control crank, this thing had a switch behind it, so you pressed it in. And that activated all these relays in this little box. And all these relays did various things. The first thing that did was it started a relaxation oscillator, which is a neon and a capacitor, and it made a tone. And the tone came out through one of these pins and went to the mic input on the transmitter. But of course the mic had to be turned off, so the relays did that. The next thing that happened is you wanted the transmitter to work, so you had a dummy load in here. You didn't want it radiating while you were netting. So it switched the aerial to the dummy load. So another relay did that. But then you wanted the receiver and the transmitter running at the same time. So another relay had to switch power to the receiver. So all these relays are doing these afterthought things. If they'd put netting in to start with, would have been great. But of course, all your control boxes were now defunct. They couldn't net, so you had to change all the control boxes to ones with the whistle-through facility. So that's what the relays actually do. Turn the sensitivity off. Of course, you don't want to overload your receiver because you want to tune your receiver and find out where the transmitter is. Turn the transmitter on, switch the audio output off, turn the oscillator on, the audio oscillator, and put the dummy load on. So, did all this. Yes, sir?
So, what did it net? How did it change the
The transmitter was on, the receiver was on. Yep. So you tuned the receiver to the whistle. Yeah, to your transmitter, yeah. And if you change frequency on the transmitter, you retune the receiver to the new crystal frequency, the new channel frequency. So here's all the relays doing this. There's the oscillator, the neon tube, the resistor and capacitor. Here's the dummy load. The antenna had to go through it. They also put in a facility to change the receiver level. So the sensitivity control could be set depending on whether you're using the military UHF band or the VHF band. So there were two. We go back to that picture. There's two whistle level preset potentiometers. Looks like a simple thing.
Did the military have a specific band that was different to general aircraft?
They used the high frequency bands, VHF, but they used the lower portion of those, about 120 to 135, which they still use nowadays. So that now is officially commercial aviation. If you listen on those bands, you'll hear Sydney Airport and Sydney Radar and all those things. And they used that for a while, but then they moved up to double that frequency to 220 to 400 megs, and that became the official military UHF band. But of course, these machines couldn't do that. They were down there in the Korean War. It's only later on that they went up there, and that's what that transverter was for, to give you access to that. So that was an afterthought as well. Oh, and of course, it was called a K-13. Oh, no, it wasn't. It was called an 0423AR. And you'll see both of them. This one's actually the military one, the 0423KR. So that's what it looks like. And by the time you hook that in, it gets a little bit more complicated. So here's your oscillator here. There's your control box. There's your other control box. There's the connections between the transmitter and receiver, but suddenly you've got all these other things to hook it in. So obviously netting is an afterthought on this machine. One of the good things they did was they made very simple racks, mounting racks. They're just battery mounts or flexible mounts, and the receiver just goes in there and clips on the front. So simple. The older ones, they had all the connectors on the back, and you had to plug them in, and you had to have special racks for all sorts of things. Here, it doesn't matter. So it's a transmitter rack, receiver rack, a mounting for the control box, and this was one of the loops, which went somewhere up in the top of the aircraft with the loop sticking out. And these were rated, this one was rated for about 150 k's an hour, and there were other ones, slimmer ones for higher speeds when they were starting to get into the jet age. This one wouldn't have been any good at the jet age. It would have either broken off or failed in some way. So the control boxes you saw were like this. But once you suddenly started to have more receivers, you had multiple control boxes or transmitters, loop control. So they built a control box with 1, 2, 3 receivers, a transmitter control and a loop control. This was for 3, but you could have 1, 2, 3, 4, 5, as many as you liked. And you buy the appropriate control box. But of course, this one's no good if you want whistle through because these don't have the press button. So they junked all those control boxes and went to these ones. So if you look in the manual, this one, which is a late manual, 1958, you'll find only half the control boxes are in here. The other ones became obsolete. How are we going for time? I'm going to have to go slower. So here's the setup I've got downstairs, which is the multiple control box, the navigation receiver with the loop, the Vhf transmitter, and the transmitter itself, with wiring going everywhere, with connectors everywhere. So how many connectors there are? I'm not using the power there, but there's 1, 2, 3, 4, 5, 6, 1 on the oscillator there, 7, and 1 underneath, 8. So at least 8 there. And that's only 2 receivers. So that one's running downstairs at the moment. You can hear the broadcast band on here. I can change it to this receiver if you like and use this one. Or we're going to run it on 2 metres later on. I have a 2 metre net with it. It's all done with Boonton cables. You can see this Boonton cable going onto the back of this dial. This Boonton cable goes onto the back of the loop dial, and this Boonton cable goes onto the back of this one. So Boonton cables everywhere. And the reason we have Bounton cables is you didn't want this junk in the cockpit, you put it somewhere else, and you only have the little control box in front of you because there's so many other things going on. So, no one's asked me a question, what is a command set yet? So, command set's not a radio, it's a function. Just like your car is not it's a car. It's not a Honda or a Holden or something. It's a car, and you can have a truck or a motorcycle. But your car can be lots and lots of things. And a command, there are many, many radios that perform the command function. So in the US Air Force, if you were flying along in a bunch of fighters, one of the fighters would say, you know, bandits coming, or go to this altitude, or go back here. So that was a command to all the aircraft. The bombers would have a command set to talk to the fighters, the fighter escort, but they also have a liaison set which would allow you to talk back to base in England or wherever. That was a high power transmitter and receiver. So there were two functions. And of course, the command sets, there were many of them. As they evolved, they used different command sets. And during, the liaison sets, they had many of those. For instance, downstairs, there's an A.R.C. 13 and a BC 348 receiver, that's a liaison set. That was used in the Pacific theatre. Whereas in Europe, they used a BC 348 and a BC 375, a huge transmitter. So they tended to, it's not a hard and fast rule, but they tended to use these sorts of radios in different theatres. So one is short range, one is long range. The Australians and the British didn't do that. We only had one radio and that served all functions. So the first ones was the SCR 183. There were 21 models of them as they evolved. The first ones only had a low power and only covered a little bit of frequency range. And then they got improved, so they had more coil boxes for them, plug-in coil boxes. The US Navy used the same things, but they gave them different numbers. The RU for the receivers and the GF for the transmitters. 11 transmitters, 19 receivers. That was just in the US Navy. So this is the US... What's that mean? Army Air Force. There was no Air Force. The Army had its own planes, and it was the US Army Air Force. The Air Force didn't start till, was it 1960? Yeah, when they had Strategic Air Command and all that stuff. That's when the Air Force started. So this is the SCR 183. But it came, as I said, in 21 models, and it came in 14 volt and 12 volt. So basically, you got a transmitter, a receiver. In the side of the transmitter, you could plug in the coil boxes to set the frequency. In the receiver, you could plug the coil boxes in the side, and they were single channel coil sets or a dual channel that you could switch to frequencies. And you had 2 control boxes for them, and an aerial changeover receiver, and a dynamotor. So they increased the power of the transmitters, they added more frequency range, 14, 28 volt, so that's why there's so many different models. So this is the Army one, the SCR 183, Army Air Force. Oh, and they're available in raw aluminium or black wrinkle. So there they were again. So when they went to war with those originally, and then the A.R.C company again said, hey, we can build a better receiver than that, because they were TRF as well. They weren't really super heterodyne receivers. The patents were owned by various people, and they had trouble. While the airlines could pay the hot money for super heterodynes and all those patents, the Army and the Navy could not. They were broke. So they used simple TRF receivers and simple triode connected transmitters. So A.R.C, who we were talking about, came up with this idea for this receiver. 1 receiver per channel. No need to change coil boxes. If you only needed 2 channels, you fitted 2 receivers or even 1 receiver. So this was the RAV, which was a Navy number. And eventually, they chose only a few of them. The RAVs are very rare, they didn't make many. The Army came up with this one, the SCR 274N, N for Navy, because they had a design, they were going ahead and it was a failure, so they had to adopt the Navy one. These are common, you'll find these everywhere. This particular one has 3 receivers, 4 transmitters to cover the same frequency, no plug-in coil boxes, 1 control box for the 3 receivers, and that's a transmitter control box for the transmitters. That's the modulator and dynamotor, and that's the aerial changeover. But of course you can get these in 3, 2 or 1 receiver, 3, 2 or 4, 3, 2, 1 transmitter. So you can mix and match those as well. And they came in raw aluminium towards the end of the war, not black wrinkle. This would be fitted to a fighter like a Mustang. 1 receiver, 1 transmitter, the aerial changeover relay, the 2 control boxes and the modulator. No, that's not mine. That's not mine, but a guy in the States. Yeah, that's right. Well, when this stuff came on the market, it was cheap. It was $5 for a receiver. $5 for a receiver. They made thousands of them. So you get hold of them and modify them for the handbands. Of course, they covered 80 metres and 7 megs. This is another one, but this one's a Navy one. This is the ARC-5. This would be in a US Navy fighter aircraft. Once again, single channel, single receiver, single transmitter. Can't see the dynamotor. Must be off to the side. Aerial changeover. Differences being, this has got a loading coil for low frequencies in the Navy, and the control boxes are slightly different. The headphones and microphone plugged in the side. The receive control box didn't have headphones on it. You had this extra box. And on the front here was a little connector giving out 28 volts and 200 volts. Yes?
They had 1625s in the finals of the...
That's correct, yeah. They were 12 volt 807.
12 volt 807.
Yeah, that's right. So there was two of these. These were a MOPA transmitter, master oscillator PA. So there was one valve for the oscillator, two for the final, and another magic eye for tuning. They had a crystal in them, and you could open this little thing and look at the window and look at the magic eye and check your dial calibration.
Presumably, the reason the modulator was the dynamometer is because they're all plate modulated.
Yes, this one was plate modulated. This is the A.R.C. It was an improvement on the SCR 274. Why doesn't that go back? Not going back. The previous one, the one I showed you before in silver, it was actually screen modulated because it was early in the war. Towards the end of the war, this one was plate modulated. There was an improvement, more power out. But, of course, suddenly the receivers were compatible, but the transmitters and dynamometers were not. So you couldn't mix and match there, so there were changes there. Once again, Bowden cables. Oh, I was talking about this connector. This connector on the front, normally there was a little plug-in drawer here. And you could pull that out, plug it in, and all it did was connect the voltage through so you could use the external control box. But you could pull this out and put in a little control box in there which had on-off and BFO and so on. Then there was another one which had a little relay in, and you could use that for instrument landing. It would turn a light on and off when the relay clicked when you found the tone. Or you could have this one which had a connector, and you could connect on various things. The voltages were there. You could connect on your wave meter. Remember the BC221 wave meter? You had to power it somehow. It had batteries in it, or you could power it from here. Or the Navy version, the LM18. So you could power that. Or there was a little unit that sat on the top called an ARR1, which was for homing as well. So that was an accessories connector. And then the last command set was this one. Receiver, transmitter, and control box. This is the ARC60. So when somebody says, I've got a command set, I saw a guy on the internet say there's 46 receivers. I don't know how many transmitters there are. 46 different ones. Oh, that's it.